definition's the first thing we get to. It's a set of points, x, y, in a plane such that the difference of the distances from two fixed points is constant. So that word difference indicates what type of operation? Subtraction, all right? And so basically that's where we get the equation for this. If you remember, the equation for a circle is basically your x squared plus your y squared equals your r squared. And that's really where we get the equation for an ellipse, right? Looks like that. And then with an ellipse, those r's are different, is basically what happens with an ellipse. You do have your HK, so, you know, we do have the process where what if it's not at 0, 0, then it's going to look something like this, right? And basically we get the equation for a hyperbola from this. So instead of the sum here, what do you think we're going to do with these if it's the difference of it? Yeah, and that's really the equation here. So if you think about an ellipse, instead of them moving towards each other, which would form a circle or an ellipse like that, they actually move away from each other. And that's where we get this particular formula. A couple things I want to point out. They do have the A's and the B's, and I don't want you to get thrown off by the A's and the B's necessarily, because you may forget which is which. First of all, you'll notice one group is positive and one group is negative. That's how you know which way it's going to open, all right? Your positive group determines how it opens. So this section here was my X group. It is positive in my formula. It opens this way, all right? On this side, my Y group is the positive group, so it opens up and down, all right? But other than that, it's the same. I also want to point out one quick thing here. My H and K always stay with my X and my Y. All right, so while it looks like H and K moved, they actually didn't. My X value of my vertex is with my X group. My Y value of my vertex is with my Y group. And that's true over here as well. My H value of my vertex is with my X group. My Y value of my vertex is with my Y group, okay? When you think about the A's and the B's, just think about the fact they are considering which way it opens or which is your positive group, okay? So when they give you a formula for your A, they just mean whichever one's under your positive group. When it's a B you're looking for, it's whichever is under your negative group, all right? So don't let the A's and B's confuse you. The A formula always follows the positive group. So again, it looks like it switches, but it's really just staying with the positive group, staying with the negative group. Something else I want to point out is when you had your ellipse formula to find your C value, because you'll notice you still have a C, you have two focal points here. You have either left and right or up and down, depending on which way it's going, all right? Your C value is a little bit different. Under your ellipse, C equaled what? It was what, 2? And how did you find it for C? A squared minus B squared, right? For this one, it's A squared plus B squared, all right? So when they go away from each other, you add the 2 and take the square root to get your C, versus when they are going the same direction, you subtract to get your C, all right? And then everything else pretty much makes sense. So my horizontal axis here is going to be my Y equals K. Y equals K. My vertical is going to be my X equals H. All right, so Y equals K, X equals H. The same thing is true here. Y equals K, X equals H. It's just that here, this is the axis that goes through it, while here, the vertical is the axis that goes through it, okay? But that should make sense to you, because you should be able to just look at it and tell me which direction it goes based on which one's positive and which one's negative, all right? The other things are also pretty intuitive. If I'm looking for my vertices, then I am going to be looking for, if it's going this direction, I'm going to be looking for my X value to change, which makes sense. If I'm going this direction, then my Y value should be changing. Co-vertices. Co-vertices, they don't help me much with the graph, honestly. Because on an ellipse, you actually join that, you actually go through those co-vertices. On the hyperbola, you don't. And so what helps you the most with graphing the hyperbola is actually these asymptotes. All right, remember an asymptote is the line that it gets infinitely close to but does not actually cross. Like you're looking for an infinite movement there when you have an asymptote. So you're going to have slanted asymptotes. Remember, we've done that. We've had vertical asymptotes, we've had horizontal asymptotes that we have found, and then we've had slanted ones where we did long division to find it. You don't have to do long division for these, but we've had those. That's what you're finding with these. A couple of things I want to point out, though. It's going to be the same equation. It's just going to have one positive and one negative slope, which makes sense. So my asymptote here, if it is going this direction, left and right, then you are going to put the value that is under your negative group on top and the value that's under your positive group on bottom. So it's B over A here, meaning whatever's under my negative group over whatever's under my positive group. But everything else is the same, either positive of that slope or negative of that slope. And then you're just graphing lines, which we hopefully all know how to graph a line, all right? And so you're just graphing those two dotted lines. So once you have your dotted lines, your vertices and your foci points, you can pretty much sketch that, what looks like a sideways parabola almost. And it gives you an idea of how wide it is based on how close those scissor type things cross. So you're gonna get a picture of how to graph or sketch that graph just based on those asymptotes. The difference over here is when it opens up and down, then you are gonna put the value that's under your positive on top versus on bottom, all right? So that's the difference in these. You wanna put what's under, basically both ways, you are putting which value is under the y on top. So y over x, right? So when you do these asymptotes, it's always gonna be the number under y over the number under x, the number under y over the number under x. So it doesn't really change. You don't have to think about A or B, just think about it's y over x. And also remember that in the equation, it is a squared, b squared. So for this slope, you're gonna have to use the square root of what you see. All right, questions on these? Graphing a hyperbola. It says graph x squared over 9 minus y minus 2 squared over 16 equals 1. So basically when I do these, I'm just going to go down this list that's in that little box above it, and I'm going to see, do I have all these pieces of the puzzle? All right. So I am going to first find my center, actually. Center is the same as it's been since circles on parabolas. It's HK. All right. They're both minus in your formula, so that's the only thing you have to really think about. So I always start with my center, and then I go from there down the list. So my center is going to be 0 and then 2. That's simple enough, all right? When I look at this, the next thing I'm going to say, is this going to open left, right, or up, down? And this is going to open left, right, because the value that is positive is my x value, all right? So I have a positive x squared something and a negative y squared something. So this guy's going to go left, right, all right? It has nothing to do with your A and B. Which one's bigger? So remember, under ellipse, the elongated had to do with which value is bigger underneath it. It does not do that with hyperbolas. Hyperbola is which group is positive. That tells you which direction it's going to go. All right, and so then I'm going to move on, and I'm going to say, okay, what is my horizontal axis here, or transverse, but my horizontal is going to be y equals my k value. My k value here is 2. That's going to be the guy that cuts through my parabola, my split parabolas, rather. All right, I'm going to look at the next piece. What are my vertices? All right, my vertices, if it is opening left and right, then my vertices should move with my x value, okay? My vertices should move with my x value. This is h plus a, so I'm going to use the value under my x here to do this. So I'm going to say 0 plus, and my a value is 3. So 0 plus 3, and then my k value doesn't change there, 2, and 0 minus 3, 2. So I'm going to have a positive 3, 2, and a negative 3, 2 for this guy right there. it wants me to find my focal points here, my foci. And so I'm going to do that. Again, if it opens left and right, my x value is what should change here. So this is h plus c, 0 plus. So I do have to find c. Remember, this is where we add the two, all right? So if I have this, I say c squared equals a squared, that's 9, plus 16. C squared is going to equal 25. That means c is going to equal 5. So I'm going to have 0 plus 5, 2, and then 0 minus 5, 2. So my focal points are going to be at 5, 2, and negative 5, 2. And then it wants me to find my asymptotes. And so for that piece, I am going to have plus or minus. It is going to be my value under my y. Remember, this is the square of that value, so that's going to be 4. Over the value under my x, that is 3. And then my x minus h, that's just x minus 0. And then plus k, which is 4. All right? And so that is how I'm going to graph my 2. I did B, sorry. K is 2, so plus 2. All right, that's how I'm going to graph my asymptotes here. All right, and so when I graph this thing, I'm going to start with my center. My center is at 0, 2. I'm actually going to then graph this guy right here, okay? And so you'll notice that it has the same y-intercept, which happens to also be where your center is, which makes perfect sense. So from your center, you're going to go up 4/3, right? So up 4 over 3, right? We're going to go this way. So this is one of them. And then I'm also going to graph that thing going the other direction with a negative 4/3 slope. This is a dashed line. It is not actually part of your graph. It is helping you direct your graph. So you can do a dashed line there. I'm going to do the same thing. I'm going to go down 4 and right 3. And I do it both directions just so I can sketch it easier. That's my way of doing it. 2 points is enough to do a line, but I always do 3 just to make it more accurate. All right, so this tells me about how wide this guy is going to be. And then I go to my to my vertices and my foci points. So I'm going to go to my vertices next, positive 3, 2, negative 3, 2. You can see how this makes a little more sense. Since they ask for this, I'm going to graph this 2, 5, 2, negative 5, 2. This actually tells me the direction anyway, and then I can sketch that graph. And so you can see this is going to be a rather wide looking set here. All right. A is not necessarily your larger one. It's always the guy under your positive, okay? And so pay attention to the fact that it doesn't matter which one's bigger here. It did when we did the ellipse. It only matters which one's under the positive group. So when you think of C over A, don't get caught up in your A's and B's. Get caught up in, like we did with an ellipse. A was really larger. Here, A is under the positive guy. And so don't flip-flop those and go straight to the larger guy when you do this eccentricity. It's the guy under the positive, which may not be the larger of the two, okay? But the same thing is true. You can find this eccentricity as well. So if you look at this next one, They've given us a hyperbola. This is not in standard form, so we are going to have to do some completing the square to get it in standard form. And then they want us to identify all the goodies that we've talked about. They do throw in the covertices here, and they've thrown in the eccentricity, all right? The other thing I want to point out with this one is pay attention to your positives and negatives. We're going to do the same process. We're going to move that constant out of the way at first, but then we are going to divide back by that constant. And so pay attention to what you're dividing by. This particular one throws in some negatives. So let's look at this. I go ahead and group my x's together based on what it looks like right now, x squared plus 18x. And then I'm looking at the fact that my y squared is negative for right now. And then I'm going to move that 41 over. And then I'm just completing the square, which we've done many, many times in this particular chapter. So I'm going to pull out that 9. Right, and I'm going to pull out that, I am pulling out a -4 here, so pay attention to what that does to your second guy. Don't let your negatives throw you off. And then I'm going to complete the square. So I have 9 times your x plus 1 quantity squared. Because I added a 1 here, right, x plus 1, x plus 2, x plus 1 is basically what I did. To pull that out, I multiply by the 9 and add a 9 over here, all right? For my y, I'm going to do the same thing, y minus 1, quantity squared. I did in this process, I did add a 1 as well, right? So it's y squared minus 2, that's a y, plus 1. So I added a 1 here, but now I'm multiplying by -4. So technically when I pull it out, it's a -4 on this side, which is a -4 on that side. Okay? Does everybody see what I did to complete the squares? So don't forget you have to multiply by this guy. And so when I do this particular one, I have my 9x plus 1 squared minus my 4, y minus 1 squared. And then this guy right here is going to be -36. So now I'm dividing by a negative, which is going to flip which guy's positive and which guy's negative, right? When I divide all of this by a -36, then all of a sudden, this is my positive guy. And so I have y minus 1 squared over my 9. That's my positive. This becomes my negative group, minus x plus 1 quantity squared over 4. That equals 1. And so pay attention to your positives and negatives. You don't actually have to flip the order if you don't want to. But it may throw you off when you start moving stuff around, all right? But you're welcome to leave it x and y with the negatives in front. You could have had negative x squared plus y squared. You can always leave it in that order if you want to. I will say standard form, if you see it on a standardized test, will never have a leading negative. So your standardized form will typically have a positive as you're leading here. But you're welcome to do it either way. So now when they want us to identify all of this, remember for your center, my center is HK. H is always with my 1, all right? I mean, it's with my x. So it doesn't matter where the x is located. My h stays with my x for these, unlike the parabola that they flipped places, right? Remember? So my h is going to be -1. My k is going to be +1. It stays with those pieces, all right? They also want me to find my vertices. So now that I have it in this order, you can see which way it's going, right? This particular one is going to open left, up and right, not left and up and down, not left and right, okay? Because of my positive being with my y, even though it looked like it was going to open the other way. So when I do my values here and I want to find my vertices, then all of a sudden my y value is going to change from center. So my x value is going to stay the same. My y value is going to go up and down, right? And so I'm going to take my positive one and I am going to add and subtract my a value here, right? So I'm going to add and subtract a value under my y here. So 1 plus my 3, 1 minus my 3 will be my 2 vertices here. So I have vertices of 4 here and minus my 3 there. All right, those are my 2 vertices. If I need to find my c value, I already have my a and my b, so my c is going to be the square root of 13, much like your problem that you just did for me, right? And so center vertices. They're asking for co-vertices. Co-vertices means your x value is going to change. So I don't typically make you find those, but we're going to add and subtract the value under your x when you do your co-vertices. So we're going to say -1 plus my 2 and -1 minus my 2, right? And then they also want my focal points and my eccentricity. Focal we've done. Let's look at eccentricity. This is where we're going to do my C value, which is my square root of 13, over my A value. My A value here is under my positive. All right. And then if they wanted us to graph, we would. The other piece that you always find here are your asymptotes. So it's going to be always a y. It's always an mx plus b form. Plus or minus what's under your y value, 3, over what's under your x value, 2. And then you do have your h and k here. H was -1, and then plus your k, which was +1. When I graph this, by the way, I would distribute and solve that in y equals mx plus b form. Okay? Just so that the graphing of it's easier. This is the standard form that you leave the asymptote in. You don't have to simplify it necessarily. But I would ask you to go ahead and simplify it. So I would distribute that and put it in y equals mx plus b. Sometimes you'll see your answer left like that. Most of the time they're going to go ahead and do distribute and add those together. So most of the time you're going to see y equals, and you'll have 2 of them when your x value does not have a because you're distributing a negative there, you're going to have 2 different y-intercepts for that guy, okay? Because the only time your y-intercept stays the same is when you have a 0 with your h, okay? Other than that, you're going to distribute and you're going to be adding 2 different things together to get that y-intercept. So don't just assume your y-intercept is the same. Yeah, so writing a standard formula, you have your vertices. If your y is changing, then it's going to open up and down, right? So they've given us our vertices. We just need to figure out what our center is. Center is, if you don't notice that, it's the midpoint formula, right? So obviously your x value of your center, you already know because that's unchanging. So that is going to just do that. For this one, you're just going to Add the 1 and the 5 and divide by 2. So you're going to get a center at 4, 3. All right. I use a capital C, and they usually do HK. Just pay attention. That doesn't mean your C value. That's actually your center. Your A value is going to be the distance like halfway through those two. So my A value is going to be a 2 there. And they've also given my eccentric. So even if I didn't know that, they've given me this. So I actually know my little c and my A there because of this. I can find my B value, because I know that C squared is A squared minus B squared. So B squared is going to be C squared minus A squared. So if I know these values here, then I can find this value. So the square root of 9 minus 4, my B is square root of 5. Basically, once I have my center and my A and B, I can write the standard equation. That's literally all I need to find it. So I can go straight to my standard form. I have, since it opens on the y, my y is going to be positive. Again, you're free to start with x all the time and do x, y. Just make sure your negatives and positives follow. I will say most of your answers in here will put the positive first. So it's going to be y minus, remember your k always goes with your y. It doesn't change order. Over your positive, which is your A value, always goes under your positive. So this is going to be 2 squared. Your x value is going to be negative here. That still goes with the h though, so minus 4 squared over my b. When I square the square root, it's just a 5 equals 1. Okay, and remember, ellipse is larger one, tells you how it's kind of stretches. The positive negative tells you how it opens for this one. Word problem. So they did the general form of the equation where they solved back into it to get it over to like all one side. We didn't do that. We just left it in the standard form. This is the part I want to point out. By examining the differences between distances, this is between lightnings, so we don't really need this part so much. We use hyperbolic functions to do something like this, and actually they go on to tell us, like, so we have 2 observers and a lightning strike happens. We model the possibilities based on this, and the model ends up being a hyperbolic function as to where that lightning could be. They actually could do a second hyperbolic function and get the pinpointed exactly as how they would do that. But we're just doing the possibilities, because we're going to look at the function itself. A couple things. The change in distance is going to be equal to double your A. So that's because your A is just half of the distance. So if we double the distance, then it's going to be 2A, right? A is just half of that distance between your 2 vertices. So the change in distance here, when we find the distance, that's going to equal my entire axis. So to find A, we would cut that entire axis in half, all right? So this is what this is telling me here. If I find my entire distance, then to find my A value, I could cut that entire distance in half. Just like if they had given me the length of an axis, right? And you were trying to figure out what A is. Well, you take the length of the axis and you'd cut it in half because it's from the center that you're trying to find. They do tell us, comparing this hyperbolic function with a second one derived from the position of another set of observers. So if you had 4 observers, you could actually pinpoint this exactly. We're just going to get a set of points. Like the lightning strike could be anywhere in this set of points is what we're going to do. So we're going to actually come up with a formula for it. So here's the example. Eric observes a lightning strike and hears the thunder 2 seconds earlier than Abby, who is standing 1 kilometer due east of Eric. If sound travels at 340 meters per second, model the possible locations of the lightning strike by writing the equation of a hyperbolic function centered at the origin with the observers at the foci. All right, so a couple things I want to point out. They have a kilometer and a meter measurement here, okay? So you'll notice here they said kilometer, here they said meters per second. So the easiest thing to do is to convert the larger to the smaller, all right? So I'm going to say that they are 1,000 meters apart, okay? So if I put Eric, Abby's Houston, due east. So if I put Eric over here, due east over here would be Abby. Their distance apart is going to be 1,000. All right, so their distance apart is 1,000. So that is going to be my C value because that's the receptor. Think about when we did satellites. That's my receptor. So that's like my focal points. That's where they received the sound back. All right. So if that is what that is, then my C is going to be 500 meters, right? So if you took your two focal points, the total distance apart, cut it in half, and you would figure out your C value because C tells you how far from center those focal points are, okay? That's what C value tells you. The distance of the actual sound is going to be how fast it travels times how long it traveled. Distance equals rate times time. That's just a fact that hopefully we've known since like Algebra 1. So if we use our information, distance equals rate times time, that's technically this little guy, the two distances, the distance between the two. So my rate, they told me my rate, 340 meters per second. They told me my time, 2 seconds, all right? So if I find my distance apart from the actual sounds, then that's going to be double my A, or my entire axis that goes from vertex to vertex. So when I multiply that out, I'm going to get, what, 680? Which means that is twice my A, right? That's all the way across. My A value is from my center. So to cut that in half, my A value is going to be 340. Everybody see that? So my focal points distance apart, cut it in half, that's going to be my C. My vertices distance apart, cut that in half, that'll be my A. So if I have A and C, what else can I get? B. And so to find my B squared, which is, if you're putting it into a formula, you don't really have to find your B unless I ask for it. Your B squared is what actually goes into your formula. So B squared is going to equal my 500 squared, that's my C squared, minus my A squared, which is 340 squared. B squared is going to be this ginormous number right here. 134, 400. I do need my A squared in my formula. So when I square that guy, you actually get this big guy right here, 115, 600. That's my A squared. That's my B squared. They told me just to center it at 0, which is what you always really do with a word problem. So once I have my center, 0, 0, my A squared and my B squared, I have my formula that represents that lightning, which is going to be just my x squared is actually my positive, so x squared over my A squared minus my y squared, that's my negative piece of it, equals 1. They actually put it into solving for y, and that was just so they could plot the points of the possible, right? So that's all they did was solve for y. I'm not going to make you graph these. I would actually ask for your standard formula here. But if you look in the book, they went ahead and solved for y. So they moved the x squared over, they divided by a negative, and then they took the square root of both sides. So solving for y is just, getting y by itself is all they did. You do have to consider, though, both of these are squared. So anytime you do this, you have a positive and negative root. Anytime you do this piece.